Okay, let me just introduce myself first. My name is Umenisha Banu. I'm a consultant trainer in Sankyana. Have been teaching data science, machine learning, statistics, artificial intelligence, and data mining with Python programming language. And along with data science, I have also been training the students, professionals, and the freshers in the field of SAS, okay, data analytics for the SAS programming language. So this is all about me. So I think many, like few of people have already was there in my last sessions. So let me just start off with the topic of discussion. Okay, so the topic of discussion for us is it is a 2-day orientation session. So the day 1 is today and the day 2 will be tomorrow. So we have a 2-day orientation session. So in that we are going to discuss about what is the importance of feature engineering. Okay, what is the importance of feature engineering and mostly used feature engineering tools and techniques for machine learning. So in case if you all are from the background of data science, if you all have the good understanding about the data science and the machine learning, so this session is for them. In case if you don't have the understanding about the machine learning and data science also, there is no problem. You will get kind of a few familiar things to understand, at least the basic things to understand in this session. So here we are going to discuss about feature engineering. In case if you all are from the data science background, as I was trying to tell earlier, you might know what is feature engineering. So for them, we are going to talk about the complete importance of what is this feature engineering, or what is this feature engineering for people who doesn't know what is feature engineering. So for everyone it goes. Okay, so when like sometimes if I just try to understand like what makes this period very exciting and enthralling for someone like me is like the democratization of the various tools and techniques out there, right? The democratization of various tools and techniques, which is followed by the boost in the computing nowadays. So that is all because we are in the world of data science now. And today, as a data scientist, like I can build a data crunching machines with complex algorithms for few dollars per hour. Okay, so it is our era which we are in, like with few dollars per hour I can create a complex algorithms. But reaching here wasn't easy, for not only for me, not only for the people who are very more good position in the data science field above me. It was not easy for them, right? So the machine learning, so we should know this machine learning is a very important component of the growing field of data science. Okay, very important growing field of data science. So like through the use of the statistical methods or the algorithms, they are trained to make the classifications, or they are trained to do some predictions and to uncover any key insights in the data mining projects or the work which has been there. So these insights, what will happen, it will subsequently drive the decision making like within the applications and businesses which is there. Like ideally we can do it for impacting the key growth metrics of the business. So as a big data, it is there available nowadays, it continues to expand, it continues to grow. The data is not getting it's not reducing, the data keeps on increasing day by day. So the market demand for the data scientist will also increase, right? So they will be a kind of a required to help and identify the most relevant business questions that the data to answer them. So if the data keeps on increasing, the data scientists also will be in more demand, so that the people who are with the data, they want the answer from the data, they want the key insights from the data. So for that reason, at least they need a data scientist. So the machine learning algorithms which are there are typically created using some kind of a frameworks like the accelerate solution development. I can use PyTorch, I can use TensorFlow, and I can create the machine learning algorithm. So here today we are going to discuss the feature engineering. So feature engineering is nothing but it is a machine learning technique that helps the data to create new variables. Okay, to create new variables that aren't in the training set. Okay, feature with the help of the feature engineering, I can create a new variable that is not there in the training set, and it can produce new features for both supervised and unsupervised machine learning. So you all might have some understanding. So first of all, I just wanted to ask in this session today, does anybody have any idea about what is machine learning? Anybody can who can volunteer to say what is machine learning? If you are feeling shy to speak up, you can also just type it in the chat box. You can plug in your informations in your chat also. What is machine learning? And what is supervised machine learning? What is unsupervised machine learning? Can anybody try to put in your views? So let's just make it interactive. It's not like I will just keep on talking and you will just listen, even though if you're understanding or not understanding, I should be able to see. So in the list of participants today, I just wanted to know how many does have a knowledge on data science and machine learning. How many are come to this session to learn or get to know what is data science or what is feature engineering or machine learning? No one?
Hello.
Yes, Willie.
Okay, how are you?
Yes, I'm good. Thank you. How are you?
Okay. Okay, I've learned data science, and
Okay.
I think with machine learning, it's a field of computer science and artificial intelligence that focuses on developing algorithms and statistical models that enable computers to learn from data and improve their performance based on their specific tasks.
Yes.
And with machine learning, we have three branches of machine learning. We have supervised learning and supervised learning. And then we also have reinforcement. So with the supervised machine learning, that is where algorithms learns from the data that is labeled and gives prediction based on it. And with unsupervised learning, the data that is being trained, it does not have labels. And then with also, I think with this one, you've not asked this one, but for reinforcement deals with where an agent learns from environment and try to respond based on what it learns. Thank you.
Thank you. As Willie and Gold has gave us a very good answer. I hope you all might have listened to it. What he told was what he was talking about. The explanation what he had given was completely right, and it was good. So machine learning is one, we are going to train the data so that it is going to learn from our past data and it is going to predict the future for us. Okay, so if I just want to put into a simple words, so this is machine learning. So there are two types of machine learning. We have supervised machine learning, not two types. There are four actually: supervised, unsupervised, semi-supervised, and reinforcement machine learning. So supervised in such that under supervision. So under supervision, so we will be training the data with the labeled data set, and then the machine will predict the future for us. So this is supervised. Unsupervised which is not under supervision. So without supervising, machine itself will learn or try to extract the features of try to differentiate from the inputs what is the difference by looking into the differences in the objects or the structure or the pattern, and then it is trying to predict, it is going to predict it for us. So that is unsupervised. So semi-supervised is nothing but both supervised and unsupervised together is semi-supervised machine learning. And then we have the next machine learning, that is reinforcement, which is nothing but we will put that in the environment according to the trial and error or trial and learn method. It is going to do its task. So that is called as reinforcement machine learning. So it was right. So when it comes to doing all these tasks, right? So feature engineering is very, very important. So sometimes it is like kept in a very low level. Without feature engineering, it is very difficult for the machine to give us a correct key insights thereover. So feature engineering in the machine learning is a kind of a machine learning technique that will leverage the data to create new variables which are not in the training set, okay, which are not in the training set. So it can produce new features for both supervised and unsupervised learning, so with the goal of simplifying and speeding up the data transformations and also enhancing the model accuracy. So why do we need feature engineering? So as to simplify and speeding up the data transformation, so also enhancing the model accuracy. So feature engineering is very much required when working with the machine learning model. So regardless of the data or the architecture, a kind of a terrible feature will have a direct impact on your model. So we will have to target that feature from that data. So this orientation, we are going to completely discuss about the machine learning feature engineering, also with its importance, and we will also discuss about the different tools which are there in the feature engineering, and you will also get to know the most important techniques for the feature engineering. Like we have encoding, we have binding, we have feature hashing, transformer, normalization, standardization. So we all these things we will get to see even with practical examples. Maybe that will be taking place. We will be doing that in a tomorrow, day 2 of the session. So this is a introduction which I had to give a very long introduction today. So now the agenda which we are going to discuss is the same thing which I had told you: machine learning and the feature engineering importance, tools, and the techniques. So these are all the things which we are going to discuss in our today's session. So what is feature engineering? Okay, feature engineering and the importance, tools, and techniques for feature engineering. In this, the first one we are going to talk or learn is what is feature engineering. So feature engineering, if I kind of put it in a proper definition, it is a process of selecting, it is a process of manipulating and transforming the raw data into the features. Okay, into the features, that features can be used in any supervised learning. So in order to make the machine learning work well on the new tasks, so it might be necessary to design and train better features, right? So as you may know, feature, when I say a feature is any measurable input. When I just talk about a feature, it is nothing but it is any measurable input that can be used in a predictive model. It is a measurable input which can be used in any predictive model. So it could be a color of an object or a sound of someone's voice. I'm just talking about only the feature. Okay, sound of someone's voice. So the feature engineering, in simple terms, is an act of converting the raw observation into the desired features. Okay, I'm just converting the raw observation into the desired features using statistical and machine learning approaches. Okay, I'm just applying the statistical and machine learning approaches to convert it into the desired feature. So the feature engineering is a machine learning technique that will help us create new variables, which I was trying to say earlier, so that it is helping us to simplify our work, so that after simplifying our work, if the work has been simplified, I can speed up the data transformations. Whatever work I want to do, I can speed up the data transformation. So whatever it is, I'm going to extract the feature which is there. So you might be thinking, say, okay, what is this feature? Raw information is there. How I'm going to convert it to extract a very important out of it feature out of it. So let's try to understand this with a simple example. So below, if you see here, they are the prices of the, in this slide, prices of the properties in the X city. So there is some city. So there is some X city which is there here. So this will help us try to understand in a much easier way about the feature engineering. So look at this prices in this X city here. It shows the area of the house and the total price. So this is the area of the house and this is the total price. So this is a square, it is in the square feet and this is in the amount. So 2,400 square feet is 9 million. 3,200 square feet is 15 million. 2,500 square feet is 10 million. So like this, they have given us the square feet and the amount. Now if you now this data which is there here, though, so this data might have some errors or it might be incorrect, or you don't know, this might have some kind of a problem with it. So not all the sources on the internet, for example, the information which is given on the internet are correct, right? So sometimes, like, to begin, we will see that we will have to add a new column to display the cost per square foot. Okay, we are, for this particular data, price data which we have, we are just creating a new column so that it is going to display cost per square foot. So there is 2,400 square feet, the amount is 9 million, but what is cost per square foot? So in 2,400 square feet, per square feet cost is 4,150. Okay, so I have 4,150. So for each values, I have each different cost per square foot value. So this feature will help us understand a lot about our data. So like how? So we have a new column here which shows cost per square foot, right? Cost per square foot. So there are three main ways. Okay, there are three main ways you can find any error. Like first one, like you can use a domain knowledge to contact the property advisor or the real estate agent and show him this per square foot rate, and you can deal with him and you can talk with him. Or the second method, like if you are a council, if your council states that the pricing per square foot cannot be less than 3,400, then you can have a kind of a analysis. So it should not be less than 3,400, but few are more, right? So you may have a problem in this particular pricing and everything. So the data can also be visualized and it can be seen. So the next way, the third way, if I say, I can visualize the data and see. So by looking into this visualization of this cost per square foot, what can you try to understand here? So when you plot data, you will notice that one price is significantly different from the rest of the other prices, right? One price is significantly different from rest of the other prices. So in this visualization method which you are seeing now, you can readily notice the problem. And the third way is using the statistics. Okay, and then third way is you're going to use the statistics to analyze your data and find any problem in your data. So first you can check into the council and you can talk to the respective people out there. The second one, you're visualizing here, you're plotting a graph, and here you're trying to get it and seeing that it is all the prices per square foot are different compared to one another. The third one, you can put a statistical approach to analyze your data and find any problem in the data. So the feature engineering consists of various processes. Okay, when I talk about feature engineering, it consists of various processes so that it can try to find the problem, extract or get the problem where it is. So the feature engineering consists of various processes. What are those processes? I have feature creation, transformation, feature extraction, exploratory data analysis, and benchmark. So what are these? So if I ask you what is feature creation, so feature creation is nothing but, so for example, like creating the features is nothing but it involves creating new variables. So I'm just feature engineering, as I was trying to tell you, I'm just creating a new variable so that I can get the input from it. So in this feature creation, I'm creating a new variable which will be most helpful for the model. So this can be adding or removing some features. So by using this this particular column, I can be adding or removing some features. So as we saw as we saw the previous example, that the cost per square feet column was a feature creation, one of our feature creation to try to understand the values between the square root and the amount there, square feet and the amount. So the next one is transformation. So what is transformation? So feature transformation is nothing but it is simply a function that transforms the feature from one representation to another representation. Okay, I'm just transforming a feature from one representation to another representation. So what is the goal here in transformation? So the goal here is to plot and visualize the data if something is not adding up with the new feature, so that we can reduce the number of the features used, or I can speed up the training, or I can increase the accuracy of certain model. So I am trying to transform the feature and see where it has a best fit. Okay, so if I try to do the transformation, I can come to an idea like whether I will have to reduce the number of features, or to speed up the training, or to increase the accuracy of the certain model. So these kind of things I will get to know with the help of transformations. And then the next one is feature extraction. So what is this feature extraction? So feature extraction, it is a process of extracting the features from a data set to identify the useful information. Okay, from the data set, I have a population population there. From this one particular data set, I'm going to extract the features and I'm going to identify the useful information. Here, while extracting the features, I am not going to alter the original relationship or the original significant information. Okay, I'm not going to do any alteration. I'm just extracting it. So this will compress the amount of the data into manageable quantities for the algorithms to process. Okay, this will compress the amount of the data into the manageable quantities for algorithms to process. So the next one is exploratory data analysis. So I have done a lot of sessions on the exploratory data analysis, where before all the machine learning algorithm, we always, before we train a model, before we create a model, we will always have to go for this exploratory data analysis, which is very, very important, EDA. So it is a powerful and a simple tool that can be used to improve your understanding of your data, right? When I do the exploratory data analysis, I am going to find out what is the shape of my data, which means how many rows it has, how many column it has, what is the information in my data, like what is my data type, what is the how many null values it has, how many non-null values it has, how can I sort out that clear that null values, whether I should use a different method to clear that null values, or should I use a mean value to insert it in the place where the data are missing. So these kind of informations I can try to get it from the exploratory data analysis. I will just have to explore the data. I will have to find the statistics of the data. Okay, and then when I use this as a simple tool, I will have a good understanding of the data by exploring each and every properties. And this technique is often applied when the goal here is to create a new hypothesis or find patterns in the data. So when are you going to use this exploratory data analysis? You don't have any idea about your data. You are just given with the data, and then you want to know what is happening with your data. Why is it happening with your data? How is it happening with your data? So all the questions you can put there. So when you want to get such kind of ideas, or you want to create a new hypothesis, there you want to find out, okay, this particular table column 1 is having a relationship with column 2, or column 3 is having a relationship with column 4. So I'm just giving a number there, not naming the columns. So when you want to know the relationship about the columns, you're going to put a hypothesis there, right? You're going to do some assumptions and you're going to find the pattern in the data. Okay, it's often used on the large amounts of the data sets, so that I can check for the qualitative or the quantitative data that haven't been analyzed before. When I haven't done the analysis before, I will be using this exploratory data analysis to extract or to get the properties of the data which is there, and I will be able to find the patterns in the data. That is EDA, or exploratory data analysis. The next one, the last one, is benchmark. So what is this benchmark model? So For example, there will be a benchmark for everything, right? Even in our families, there will be a benchmark. For example, I will be always compared with my elder brother. So he is doing well by look at his performance. He is doing well. You're not doing well. So always my parents used to compare. Okay, see, you are always lagging, but he is always active. So these kind of comparison. I'm just giving an example. I don't know if it happens in all the houses, but in my house, every time this happens, and I always get worried there. Okay, so there is a benchmark. My brother is a benchmark here. So in such a way, a benchmark model is a most user friendly, dependable, transparent, and interpretable model, so that against which you can measure your own. Okay, here you're doing a comparison. Okay, here you're trying to go for a comparison. So it's a good idea whenever you have a data set to run the test data set to see if your new machine learning, so you have created a new machine learning models, and you want to check if that new machine learning model outperforms a recognized benchmark. So already there is a recognized model which is there, which is present. So we are going to compare whether the new one which you have created outperforms the benchmark or not. Okay, so these benchmarks are often used as a measure for comparing the performance between the different machine learning models. Like we have neural network models, support vector machines, linear or non-linear classifiers, or different approaches like we have bagging and boosting. So for all these, we try to use a benchmark to find out the, or to compare whether one outperforms the other or not. So these are the few feature engineering processes which we try to utilize there, use there, and we try to do the feature engineering. So the next one which we are going to discuss is what is the importance of feature engineering. So when I talk about the importance of feature engineering, it is an important step in the machine learning model where the feature engineering, it refers to the process of designing the artificial features into an algorithm. So we are going to design the artificial features into an algorithm. So most importantly, I just wanted to say this in simple terms, this feature engineering is nothing but where I am going to make the machine understand what a human is talking. For example, I'm just putting it in a simple words. With the help of the feature engineering, I have different in my data. I have different types of ranges or values, right? I might have date column, I might have salary column, I have categorical column by listing out from which college you are, what qualification you have completed. One might be B Farm, one might be like B Farm, one might be B Tech, one might have completed his masters in statistics or economics. So there will be a different unique values and categorical values. So name is also one of the kind of a categorical value. Okay, so what kind of job he does, what kind of position he holds, that is also one of the categorical value. So I have different categorical value, different numerical value, and I have dates and time also as well. So when I have numerics, will be able to easily understand with by the mission. Here with the help of the feature engineering, what I am trying to do is I am trying to convert all the categorical values to the numerical values, so that I am doing it in a machine readable form. So okay, I'm converting everything into a machine readable form, so that machine, I'm going to train the machine. So before the machine gets trained, I am going to train the machine with the numerical data. So how will I train the machine with all the numerical data? My data is having a categorical also, dates also, numerics also. But how will I convert all the data points to the numeric, the categories? That is what the feature engineering is. We are going to train the machine in a machine readable form. So how I'm going to put it in a machine readable form? With the help of feature engineering, I'm going to train the machine so that all the categorical will be changed into a numerical values, and it will be done. So this is a simple explanation, a short information which I'm just trying to make you understand about this feature engineering. So this feature engineering is referred, as I was trying to tell you, these artificial features when we are trying to add, like they are used by that algorithm in order to improve its performance. Okay, only when I do it in a machine understandable way, it will improve its performance, or other words, it will help us to reap the better results. So the data scientist, most of the time, they spend most of their time with the data, and it becomes very important to make the models very accurate, right? So when the feature engineering activities are done correctly, okay, when the feature engineering activities are done correctly, the resulting data set is optimal, and it can contain all the important factors that affects the business problem. It consists of all the important factors which is going to affect the business problem. So when I'm telling I'm going to convert all the categorical information to the numeric numbers, so it's not like I'm going to change the value of that. Okay, I'm not going to change the value of it. The value is going to be the same, the data value is going to be the same, just it is being transformed or converted to the numbers there. So as a result of these data sets, what happens, the most accurate predictive models and the most useful insights are produced when I do this feature engineering. So people who does have the knowledge about machine learning, or who does have the knowledge about data science, you might also have known about deep learning. So can anybody say what is deep learning? So we are talking about the importance of feature engineering. There is a small relationship with this feature engineering, machine learning, and the deep learning. So just anyone who does have any idea about what is deep learning in today's session?
Hello.
Yes, Willie, you can.
Okay, thank you. I think deep learning is it's a field of machine learning actually that involves it trains the artificial neural networks to recognize patterns in the data by using multiple layers or like interconnected nodes that is called neurons. These are designed normally to represent data and stacking layers. Yeah.
Yes. So what is the difference between machine learning and deep learning?
The difference between machine learning and the difference between deep learning and machine learning. Yeah. With machine learning is a field. It's a field. It's a whole field of computer science and artificial intelligence. And it focuses on developing algorithms, and it uses statistical models. But with deep learning, actually, it's a subfield of machine learning that only involves the training of artificial neural networks to recognize patterns in data.
Yes. Are we in the deep learning, are we going to give the labels or anything?
With deep learning, actually, there are labels. There are labels because when you are training models, actually, let's say the one for image classification. Yeah, there is one that I think I did. It was about it was this challenge that was on Cindy, Africa. The data had labels. Actually, it was for sign language, the sign language challenge. I think you saw it. It had labels actually, and then you train on it, and you use the neurons. You use something. You use like there were 5 layers. The CNN. You know the convolution neural network. You use it. It includes 5 interconnected neurons. Yeah, which actually where the data is fed into, and then it is able to classify at the end of it. I think there is a pulling out layer, right? From there now it gives what that the classification of the image that you fed based on undergoing the neural recognition in the pattern, and then it gives now the output.
Okay, fine then. Thank you, Willie. Thank you so much for your views here, for your views and ideas, what you had given here. When it comes to machine learning, And deep learning, machine learning, we are going to give like user is going to give the labeled, sometimes the labels and everything. In most of the cases when it comes to deep learning, there we are like the deep learning itself will extract the features with the help of the neurons, the nodes which is present in there. Okay, that's the reason sometimes what happens when the feature engineering had when people asked to do the feature engineering, people they try to ask what is the need for this feature engineering as a data centric approach when we have a deep learning. Because deep learning itself, in the deep learning process or technique itself, the feature extraction happens automatically. And one more thing, when it comes to deep learning, another kind of a drawback is that when I want to do a deep learning, I should have a large amount of data set. Okay, I should have a large amount of data set with me. So when they try to ask why this feature engineering is very much needed when there is a deep learning, okay, there the feature extraction is happening, why we are doing doing separately the feature engineering. So this approach, the feature engineering approach, is useful for whenever we have a use cases where it is very costly. Okay, because deep learning sometimes it's very costly, right? So when it is very costly or otherwise difficult to collect the large amount of data sets, we don't have a very large amount of data sets with us. So during that situation, we can go for the approach which is called as feature engineering. So this might be a case like when the data is difficult to access, or when there is a strict regulation or other barriers, or barriers like to collecting or storing the large amount of amounts of data. Like examples, I can go and give a lot more examples over there. So for example, if I try to give in the manufacturing sector, okay, in the manufacturing sector, like equipping the production facilities with a comprehensive sensor technology and connecting them with a database is very expensive, right? I have a production facility with comprehensive sensor technology, I want to connect it with the database. It is a kind of a very expensive. So as a result, what happens, many plants there which do not collect the data at all, they will not go and collect the data at all. And when the machines are able to collect and store the data, they rarely connected to the data the lakes, the data lakes which is present there. So when we don't have data at all, then it is very difficult to go for the deep learning process. And we can also go for another example like the supply chain. So in the supply chain context, like every company has their has only a certain number of orders that it processes every day. So if we want to predict and if we want to demand for a product that is very irregular, very irregular demand, so we sometimes have only a few data points available. So during that situation, we have feature engineering, we cannot go with the deep learning process. So in such areas, like feature engineering probably has a greatest leverage for us to use the performance of the models over there. So like the creativity of the engineers and the data scientists is required to enhance the data quality, okay, data set quality to a sufficient level so that the process is really straightforward. But you will have to go for experimental, and it is a very iterative process. You all know the meaning of iterative, iterative, it should go step by step, line by line. So that is the process of this feature engineering. So like whenever, for example, let's say for example, when a humans try to analyze the data, okay, when a human is trying to analyze the data, so they often use their past knowledge and the experience. So what will I do when I have to analyze the data? I will use my past knowledge and experience to help understand the patterns, and I will try to make the prediction. For example, if someone is trying to estimate the temperature in different countries, so I want so somebody they wanted to estimate the temperature in different countries, they might consider the location of the country. Okay, they might consider the location of the country relative to the equator. Okay, so this is just an example. So since they know that the temperature tend to be a little bit higher near the equator, so they are going to consider the location which is where the location of the country which is relative to the equator. So this is a human knowledge on it. However, when I give a machine learning model to do the same task, same understanding of the concept and the relationship as a human does will not be there with the machine learning, right? Because they only learn from the data which is being given from us, right? So therefore, any background information or context that a human would use to solve a problem must be explicitly included in the data set in a numerical form. So we have trained the data, but in case if you have your conceptual knowledge on that one particular problem which has been facing, when you have that knowledge, you can explicitly include. When I say explicitly include, means you are giving explicitly giving that particular information to that machine to get even that information to be considered while doing the predictions. So explicitly I will be including in the data set, but I will have to include it in the numerical form. So what data do we need to make the model smarter than a human? What kind of data should we need to give to the model smarter to make it smarter than a human? So if they kind of put in such kind of a question, we could use the Google Maps to find the location. I'm talking about the example of the location of the the coordinates, the latitude and the longitude. The example which I try to give on the understanding about the equator, that is a temperatures in that particular country. So I will use a Google map to find the location coordinates where about the latitude and the longitude information of each country. So additionally, I can also gather the information about the altitude of the region and the distance from the nearest water bodies of each country, and I can try to give it to the machine. Explicitly I can program it to the machine. I can collect this extra data so that I can identify and consider what possible factors that could affect the temperature in each country, along with the machine which is already been trained with the other data. So humans knowledge also I'm going to input there along with the machine which is already doing its own job there. So that is also coming under the feature engineering task only. So let's say we have collected some data, and that data might have some impact on the temperature. Okay, the data which we have collected have some impact on the temperature. So what next? What should I do next? Okay, once I have the data which is going to have some impact on the temperature, which the machine is not having the knowledge about. So what should I do next? So once we have enough data that will describe the characteristics of the problem which is happening there, we will have to make sure that the computer can understand the data first. Right, what we are going to give, the computer should understand the data there. So the categorical data, the dates, etc., must be converted into the numerical values. So all the data values must be categorical, dates, data, everything should be converted into the numerical values. So here we will be discussing about few tools, how we are going to which was used on preparing the raw data. And then next session tomorrow we will be discussing about the techniques which are there in the which we are going to use for the feature engineering. So when it comes to the tools, so like the few best feature engineering tools which is most time used out in the industries, okay, which is most outly used in the industries are like there are many tools which will help you in automating the entire feature engineering process, and it can produce a large pool of features in a very short period of time. Okay, for both classification and regression tasks. So machine learning, we have classification and regressions, right? So let's have a look at some of the feature engineering tools. The first one which we are going to talk is feature tools. Okay, the name of the tool is feature tools. So what is this feature tools? Feature tools is a kind of a framework. It will help to perform the automated feature engineering. So automated, it is completely automated. So it excels on transforming temporal and relational data sets. I can use a relational data sets into feature matrices for machine learning. So this feature tools which is there, it will integrate with the machine learning pipeline building tools you already have. Okay, what this feature tools it will do, it will integrate with the machine learning pipeline building tools which you already have in a fraction of time. It will take to complete the whole task and it will do it so that you can also use load the pandas data frames and automatically construct a significant features with the help of this feature tool. So if you can see, there are lots of summaries which is being listed out here. What are the feature tool summary? What can it do? It is easy to get started. Good documentation and community support is there for this feature tool, and it helps you construct meaningful features for machine learning and predictive modeling, so that it is going to combine the raw data set with the like with what you know about your data. So I can also give my inputs, my own new variable which data which I want to add there, I can add there and explicitly add there, and it can work on it. It provides different APIs also to verify that only the legitimate data is utilized for calculations or preventing the label leakage in your feature vectors. Those informations also I can get, and it is good at handling the relational databases. Okay, so the next tool which we are going to see is AutoFeed. So AutoFeed is another tool, but here the AutoFeed problem is that it will not work with the relational data. It can work only with a single data. Okay, it will not work with the relational. So what is the meaning of relational data? And relational data is nothing but a complete database, relational databases. So it is not going to work with the relational data, two or more tables. Okay, AutoFit will work only with a single table. So it will help to perform linear prediction models with automated feature engineering. This is also an automated feature engineering. You give in the data to it, it will do the feature engineering process completely, and it does the feature engineering most of the time for the it can handle easily the categorical features with one hot encoding. So tomorrow we will see with a practical example of what is that one hot encoding. So this AutoFit allows you to select the units of the input variables, so that it, in order to avoid the construction of physically nonsensical features. So any nonsensical features are there, it is going to avoid it. It is not going to take it into the consideration, and it is used for most of the time for logistical data. And also you'll have to remember, it is not good in handling the relational data. It is only handles the single data. The next one which we are going to look into is TS-Fresh, is another tool which is used. It is a Python package. Okay, TS-Fresh is a Python package. It calculates a huge number of time series. What does this TS-Fresh does? It will calculate a huge number of time series characteristics. Or when I have or the features like in addition, like this particular package, it will include methods for accessing the explanatory power and significance of such traits in regression and classification tasks. So it will try to understand that. It is the best open source Python tool. Okay, this is a best open source Python tool which is available for time series classification and regression issues. So it helps to extract things such as number of the peaks, average value, maximum value, time reversal, symmetric statistics. Like this, each and everything it will try to extract. It can be integrated with the feature tools as well to do its task. And here also TS-Fresh will work only on the single table. And then we have 1BM. 1BM is also a feature engineering tool. It interacts directly with the databases raw table. Okay, it interacts directly with the databases raw tables, and it slowly joins the tables, like taking the different parts on the relational tree. It recognizes simple data types there, like numerical or categorical, whatever data types is there, it will recognize. And it the complicated data types, like the set of numbers are there or set of categories are there with me. Or if I have another complicated data types, I have a sequence, I have time series, I have different text columns. So these kind of conditions also 1BM will try to handle, and it will give a complete result and applies a predefined feature engineering approaches there. Okay, it will handle the relational and non-relational data in this. And the next one is Explore Kit. So what does this Explore Kit does? This Explore Kit, based on the idea that that extremely informative, like we have extremely informative features, like they are typically the consequences of manipulating or basic ones. In the basic ones, I can manipulate it. This Explore Kit identifies the columns Okay, it identifies the column and the common operators, so that to alter each of the feature independently or by combining the multiple of them. So it combines, or each of it separately it will try to understand. So with this particular explore kit, you can use the complete where you can use a complete huge data, metadata kind of thing, and you can work on it like a kind of a for a relational databases. You can handle with the relational databases to extract the do this feature engineering. So if you see, this is a complete summary which is being given here. These are the advantages of each tools which is here. So advantages of feature tool: it is very most popular, good community support, good handling relational databases, auto feed, similar to understand, simpler to understand, easy to use, good for non-statisticians. It does in a single table, it does its own job. TS Fresh is there, easily integrated with the feature tools. And then 1BM, both relational and non-relational data are supported. It generates both simple and complicated features also. And then we have the certain limitations. It does not have support for unstructured data. It creates large number of features. Okay, when I try to give, it also tries to, when it is trying to extract the good things, it is also trying to create a more new variables there, which will also try to become a problem for us. And then auto feed, it cannot handle the missing values. AutoFit cannot handle the missing values, and it lacks many common and important features. It will lack many common and important features. And the TS Fresh only good for supervised learning. I cannot use the TS Fresh for unsupervised or reinforcement or any other machine learning. And then 1BM is there. It is a like no open source implementation is there for 1BM. Okay, and it is supported data types. You can, if you can see, feature tool supports relational tables. AutoFit will work only with a single table. TS Fresh will also work with a single table, and 1BM will work with relational tables. So if you go for open source implementation, feature tools, yes, it is an open source. AutoFit is an also open source. 1BM is not a open source, and that is its limitation as well. No open source implementation is there. Other than that, it works good for both relational and non-relational data which are supported, and it will generate both simple and complicated features. So which is well and good, but one limitation is that it is not an open source implementation. Okay, so this is all about the techniques. So the feature engineering is nothing but it is a development of a new data features from the raw data. I'm going to create a new data features from the raw data. So with this tools we are going to do, they will industries, most of the industries try to do it. So in the tomorrow's session, we will be continuing with the techniques which are used in the feature engineering. Okay, we will be starting with the different techniques which are used in the feature engineering. So as for today's session, if anybody is having any doubts, you can ask me. If anybody is having any technical